Hey everyone, and welcome back to the channel. Today we're diving deep into a force that literally keeps our feet on the ground, but is way weirder than you might think. We're talking about gravity. You probably learned in school that it's a constant, pulling everything down at the same rate. Well, that's not entirely true. Let's unravel some of the strangest facts about Earth's gravity. First up, did you know that gravity isn't the same everywhere on Earth? It's true. If you were to travel from the equator to one of the poles, you would actually get slightly heavier. Why? Because the Earth isn't a perfect sphere. It's an oblate spheroid, meaning it bulges at the equator and is flatter at the poles. This means the poles are closer to the Earth's center of mass, so gravity's pull is a tiny bit stronger there. On top of that, the planet's rotation creates a centrifugal force that slightly counteracts gravity, and this effect is strongest at the equator. So, if you're looking for an easy way to lose a little weight, just hang out near the equator. Now let's talk about some real gravitational anomalies. There's a place in Canada called the Hudson Bay area that has baffled scientists for decades. Gravity there is significantly weaker than in surrounding regions. For a long time, the leading theory was that a massive ice sheet during the last ice age pushed down the land. When the ice melted, the land started to slowly rebound, but it hasn't fully recovered yet, leaving a dent in the Earth's mass and a weaker gravitational pull. However, recent research suggests another factor. Massive convection currents deep within the Earth's mantle are pulling the continental plates down, contributing to this gravitational low. It's a double whammy of geological weirdness. And it's not just big regions. There are smaller, localized spots known as gravity hills or magnetic hills all over the world. These are places where it looks like your car, if you put it in neutral, will roll uphill, defying gravity. It's a spooky optical illusion. What's really happening is that the surrounding landscape is tilted in a way that tricks your brain. The horizon line is obscured or skewed, making a slight downhill slope appear to be an uphill one. So, while it seems like a mysterious force is pulling you upward, it's just your perception playing tricks on you, all thanks to the lay of the land. It's a perfect example of how our senses can be easily fooled. But what if you could actually escape gravity's pull, even for a moment? That's what happens in microgravity. Astronauts on the International Space Station aren't floating because there's no gravity. In fact, the ISS experiences about 90% of the gravity we feel on the surface. So why do they float? The answer is that they are in a constant state of freefall. The station is continuously falling towards Earth, but it does also moving forward at such a high speed, about 17,500 miles per hour, that it constantly misses the planet. It's like throwing a ball so hard it orbits the Earth. This continuous fall creates the sensation of weightlessness. It's not a lack of gravity, but a perpetual dance with it. Finally, let's get really mind-bending. According to Einstein's theory of general relativity, gravity isn't a force in the traditional sense at all. Instead, it's a consequence of mass warping the fabric of space-time. Imagine placing a bowling ball on a trampoline. It creates a curve or a well. If you then roll a marble nearby, it will follow that curve and spiral towards the bowling ball. That's essentially what planets, stars, and galaxies are doing. They are bending space-time, and other objects are just following the straightest possible path through that curved space-time. So the Earth isn't pulling you down. It's warping the reality around you, and you're just moving through it. How cool is that? From making you weigh less at the equator to creating mind-bending optical illusions and shaping the very fabric of the cosmos, gravity is far from simple. It's a dynamic, mysterious, and fascinating aspect of our universe. Thanks for joining me on this gravitational journey today. If you enjoyed this video and learned something new, don't forget to hit that like button, subscribe, and ring the notification bell so you don't miss our next adventure. See you in the next one.